A compiler is a translator. It allows humans to talk to computers. But how does it work? Well, that's what I wanted to know, so I rebuilt a compiler from complete scratch to teach you how it works. If you imagine a compiler as a 4-step pipeline, then I will explain the first step, the tokenization, in this video. But what does a tokenizer actually do? Well, a tokenizer breaks up your code into objects called tokens. Think of a token as a word in a programming language, which is the smallest sequence of characters that still carries meaning. For example, if you tokenize this JavaScript code, you will end up with these tokens. Just like how a word in English can be a noun, verb, adjective, etc., each token has a type that represents the token's meaning. By the end of this video, you and I will have built a working tokenizer that can tokenize this code snippet. But on our way there, we'll tackle 3 increasingly difficult challenges, each tougher than the last. Before we get started though, you need to understand parsing. Parsing breaks code into structured pieces the compiler understands. We use it to identify basic building blocks like symbols and keywords before handling more complex parts. Speaking of complex parts, let's tackle challenge 1, trying to parse out the simplest tokens first, the ones that are only 1 character long. In the code snippet we're parsing, that will be all of the following tokens. We'll start by iterating through every character of our input. But now as we iterate through the code string, we check if the current character is one of these single character tokens, and if it is, we add the character to the final tokens list. Now, one way to check if a character is a single character token is to keep a list of all single character tokens we support and check if the character is in that list. With the single character tokens out of the way, we need to tackle a harder challenge, because the next thing we need to do is parse the identifier and keyword tokens. An identifier, at least for our purpose, is any sequence of alphabetical characters. So if the current character is alphabetical, we start parsing an identifier. We keep adding characters to the current identifier token until the current character is not alphabetical. But some words like function, while, and switch have a special meaning in JavaScript and therefore cannot be used as regular identifiers. This group of identifiers is called keywords. So here it gets tricky. How does the tokenizer differentiate between an identifier and a keyword? Well, we can apply the same procedure we used in challenge 1 with the single character tokens. We keep a set of known keywords, and when we're parsing an identifier, we check if the parsed name is in the set. If it is, we change the token's type to the keyword's type. For our last and hardest part, we need to tokenize the hello world part of our code snippet, also known as a string literal. In JavaScript, a string literal starts and ends with apostrophes or double quotes and cannot span multiple lines. To make things less hard, we will only support apostrophes, and multiple line strings. To tokenize a string literal, we're going to do something similar to tokenizing identifiers. Except we only stop when we reach another apostrophe. So if the current character is an apostrophe, we start parsing a string literal. We keep collecting characters until either the current character is another apostrophe, marking the end of the string, or until we reach the end of the file, making the string an error. And there we have our basic tokenizer being the first part of a compiler. Now YouTube thinks you like this video next. Let's see if they're right.